Hello 3-1s, we're looking at lesson 5.1, graphing sine and the cosine function. So we're going to start looking at the graphs, but we're going to do a recap from yesterday first. So we're going to solve for the angle as long as it is between 0 and 360 degrees. And it's giving the equation 2 cos squared theta plus cos theta equals 0. So what I would do first is I would factor the cos from both the 2 cos squared theta and the cos theta. So that would be cos theta in front of cos, so 2 cos theta plus 1 once you factor it out. So that's equal to 0. Then you could take each factor and make it equal to 0. So cos theta could equal 0, and 2 cos theta plus 1 could equal 0. So we want to find out where cos theta equals 0, so I'm going to use the quadrantal angles. So this is 1, 0, 0, 1, negative 1, 0, and then 0 and negative 1. So remember, the x-coordinate is always cos, and the y-coordinate is always sine. So we want to see where the x-coordinate is 0. So that's going to happen in two places. That's going to happen here and here. So those are the two places where cos theta equals 0. So that occurs at, since we're in degree mode, that's going to occur at 90 degrees, and it's going to occur as well at 270 degrees. So those are my two answers for the first one. So that's what theta could equal. Now we want to solve for cos in this second case. Cos theta equals negative 1 over 2. So in this case, we want to find out where cos theta equals 1 over 2, so we can go cos inverse of 1 over 2. We always do the absolute of this value. So cos, so the angle is equal to, this is the reference angle that we're looking at, cos theta, the inverse of 1/2 equals 60 degrees. So I know that my reference angle is 60 degrees, and that because cos is negative, using the cast rule, C-A-S-T, cos is negative in your second and your third quadrant. So we need to find an answer in quadrant number 2 and then quadrant number 3 to get our final answer. So in quadrant number 2, we're going to go 180 minus 60 degrees. And that equals 120 degrees. And then in quadrant number 3, we always have to do 180 plus the reference angle. So 180 plus 60 equals 240 degrees. So those are our four answers that we would need to solve for this single equation here. So that would be all the answers that we need. Okay, so sine and cosine functions. So sine and cosine are called periodic functions. Why? Because they repeat themselves over a specified period. So they're going to be a wave shape. So the sine graph is a graph where the function you graph y equals sine of theta. You can also describe a sine graph as a sinusoidal curve. So in this case, what I want you guys to realize is that when we're looking at the graph, you'll notice that it goes through 0, 0, and then it goes to a maximum of 1 at pi over 2, and then it goes to a minimum of negative 1 at 3 pi over 2. Remember, pi over 2 is 90 degrees, and then 3 pi over 2 is 270 degrees. So that right there, and then it comes back to its original starting point right here at 270 degrees, or sorry, at 360 degrees. So that makes one wave shape. So that is one cycle, one revolution around the circle. And then it repeats itself, going either counterclockwise or clockwise. So we can go to the left of there, or we can go to the right and make the angle positive. So what we want to remember is that the period is the length of the interval of the domain over which a graph repeats itself. So the length so we're looking at the domain and we're saying, how long does it take for the graph to repeat itself and start itself all over again. So another name for it is it's the horizontal length of one cycle of a periodic graph. So for sine and cos, it's 2 pi. Now that can change if we shrink the graph or if we compress it, but for the most part, it's 2 pi. So that's one cycle or one revolution around the circle. Our amplitude is the max vertical distance the graph varies above and below the horizontal median point. A way of solving for that is your amplitude is always equal to your maximum height, so your max y coordinate, minus your minimum y coordinate. And then you would take those values and divide it by 2. So the a for sine and cos, if there's no other transformations, would be 1. Okay, so let's look at the period of y equals sine of b of x and y equals cos of b of x. So what you'll notice is that there is a horizontal stretch. That b value is that horizontal stretch. So what b does is b alters the period of sine or cos from 2 pi. So normally it's at 2 pi, but if you see that there's a value in front of x, it's not going to be 2 pi. So our x value is going to go from 0 to 2 pi. Now, if there is a stretch, what it's going to look like is your b is going to be, your x is going to be absolute of b of x is less than or equal to 2 pi. And what we want to do is isolate for x by dividing both sides by the absolute of b. So that's going to look like 0 divided by absolute of b will stay as 0, but 2 pi, when you divide it by the absolute of b, it stays like that. So this is going to be your new period. Your new period. So this is the equation that you will use if you're in radian mode. If you're in degrees, to find out your stretch, or to find out your period is equal to 360 degrees divided by your absolute of b. So that's when you're in degree mode. So example number 1, they're giving us on the same axis of the graph, y equals, we want to graph them, 6 cos of x and negative 4 cos of x. We're going to go from 0 to 2 pi. So we're going to state the amplitude of each graph. And what we're going to do is describe them. And as we describe them, it will help us figure out what this graph actually looks like. So we're going to start with A. And we're going to describe them both. Okay, so we know that with this case, we have a vertical stretch by a factor of 6 about the x-axis. versus the y equals -4 cos of x, we have also a vertical stretch factor of 4 about the x-axis. We also have a reflection about the x-axis. So let's determine what our amplitude is and our period. So our amplitude is actually going to be the value in front of your cos of x or your sine of x. So in this case, it's going to be the same as your stretch, your vertical stretch factor. So your amplitude is going to be 6. And your period, because there's no value in front of x, there's no horizontal stretch, your period will be 2 pi. So because we're in radians, we need to make sure that our answers are in radians as well. Our amplitude is equal to A equals 4. So it's always the absolute of the value in front of. So it's always your vertical stretch, kind of, if you look at that. And then your period, again, there's no value in front of x, no horizontal stretch, so it's still 2 pi. Okay, so what I'm going to do is I'm going to graph this in my calculator. So in my calculator, when I put these values in, I'm going to go to 6 cos of x, and I'm going to change my mode to be in radians mode. So you need to change your mode to be in radians mode, press enter, and then you're going to have to adjust your window to go from 0 to 2 pi. So you're going to have to go x minimum is 0 and your x maximum is 2 pi. And then for your window, I would set it from -10 to +10 for now, and you can adjust it if you have to. So I know that if you go to second graph and you look at your table of values, you can then plot some values. So I'm going to start by sketching a few values here. So I want to go by 2s, 2, 4, 6, 8. -2, -4, -6, and -8. Okay, and then my domain is already written. My x-axis is already labeled. So there's your x-axis, there's your y-axis. So I know that if I graph it, for my first graph of A, 6 cos of x, I'm going to use one color for that one. I'm going to use red to represent that. And I'll use, let's try blue to represent this one. So my red one has a y-intercept of 0 and 6. And then if you graph it, you can then press trace and find out what values it is at pi over 2. So you're going to go trace and then pi divided by 2 for your x value, and that will give you that pi over 2 will equal 0. So that is an x-intercept. Now, if we do, so this is because it's cos, we know that at 90 degrees it's at an x-intercept, and at 270 degrees it's at an x-intercept. So again, I'm going to go trace and put 3 pi divided by 2, and I know that's going to also equal an x-intercept. Then you can go trace and put in pi, and pi is equal to -6, so that's your minimum value. So it starts at your maximum, goes down to pi over 2, which is at your x-intercept, then it goes to your minimum value, and then it comes to your x-axis, and then at 2 pi, if you trace 2 pi, you should find that the value is, when you trace 2 pi, you should equal the maximum again, which is +6. So this is what y equals 6 cos of x looks like. And then what I did was I just used my graphing calculator, the table of values, and then I used my tracing to find out what pi over 2 was, pi and 3 pi over 2, because those are irrational numbers. So what I want to do is make sure that if I put it in that they're exact. So I'm putting in pi over 2, 3 pi over 2, and 2 pi. Now I'm going to use blue to graph the other one. So I'm going to graph in my calculator -4 cos of x. So again, I can find the y-intercept by going trace 0, enter, and I get that -4 is going to be my starting value. So at -4, because there's a reflection, now instead of it being a maximum, it's now a minimum. And then again, if you go trace and put in pi divided by 2, you should find that that is an x-intercept. So it has the same x-intercepts as the red one. And then at pi, if you go trace and put in pi, enter, you should get that it's equal to +4. So that's your maximum. And I'm just going to connect all these values here, giving it a nice wave shape. And then at 2 pi, you should see that it returns to that minimum value of -4. So again, it's symmetrical. There are arrows on either sides because it does continue on forever. But since our domain is saying from 0 to 2 pi, you don't technically have to include them because our graph is giving us and asking us only to graph within the domain from 0 to 2 pi, and then we're done. And then they also want us to compare this graph to cos of x. So I'm going to do cos of x now with orange. So cos of x always starts at the maximum of 1. And then what it does is it goes to the x-intercept of pi over 2. And then it reaches the minimum of -1 at pi. So it looks like the red one. Then it reaches the x-intercept again at 3 pi over 2. And then it reaches its maximum at 2 pi. Okay, so all it is it looks like the red one, but because there was a 6 in front of cos x, it just stretched it up higher and lower for the minimum. So it changed your height, your maximum, and your minimum. And then the blue one doesn't look exactly the same because there was a reflection that flipped it over. Okay, so consider the period, amplitude, domain, and range. So if we're looking at cos, I'm just going to write down those features. So with cos of x, the period should always be 2 pi. Just like the ones that we had, there was no value in front of x. Your amplitude is 1, so the height above your midpoint is equal to 1. And your domain, in this case, your domain is going to be normally XCR, but in this case, we're going from, we're using the domain that they gave us, so we're going to use the same one, but normally it's XCR. It does continue on forever, but you're going to use the domain that they gave us in the question. So this is what we're using for our domain. And then XCR. And then for Y, our graph, if there's no stretch to it, will always go from -1 to +1. And now if you were looking at the blue one, it will have the same domain. So the domain for the blue one will be from 0 to 2 pi. Again, because it's written in the question. And our range will go from y is greater than or equal to -4 to +4 YER. And then our red one, which is the 6 cos of x, our domain is going to be x such that x is greater than or equal to 0, less than and equal to 2 pi XER. And your range is going to be y such that y is greater than or equal to -6 and less than and equal to -6 YER. So this is just showing you that your vertical stretch affects your range. And then D, they're just asking for the amplitude. So the amplitude for 1.5 cos of x would be this value. So amplitude would equal 1.5. So it's always equal to your vertical stretch value only, the factor. Okay, so that's example number 1. Example number 2, they want us to sketch cos of 3x. So what you can notice is that there's a 3, so that is a horizontal stretch. And so that's a stretch of 1/3 about the y-axis. Okay, so they're also telling us to go from 0 to 360, so we want to be in degree mode in this one. And we want to state the period of the function and compare the graph to y equals cos of x. So I'm going to start by graphing cos of x here. So I'm going to do that in orange, and that way you can see it. So with this one, I'm going to stretch it out a little bit and put +1 here and then -1 here. Okay, so at 0, it should be at the maximum for cos at 1, and then it goes through the x-axis at 90 degrees, and then it goes to the minimum at -1. At 270, it reaches the x-intercept, and then at 360, it should be the maximum again. It comes back to its starting position. So I'm going to sketch what this graph looks like. This is the cos one. So this is cos of x. And now what they want us to do is also on the same graph. Well, actually, they give us 2 graphs. So what we can do is graph now. On the same graph, we're going to graph cos of 3x. Now with this one, you want to change your domain, your mode to be in degree mode now. So mode will be in degree modes. So once you graph it, make sure that you change your window. Your window has to go from 0 to 360 for your x values. And then your y will go from maybe -2 to +2. Okay, so you want it to look like a nice wave shape if you're doing this properly. So I'm going to do, this is my cos of 3x. Okay, so if you guys look at the table of values, you'll notice that, or actually it's even better to just go trace 0 enter. So at trace 0 enter, I know that the y-intercept doesn't change. They're identical, so they're going to be the same points. But then what you should notice is that our x-intercept is not the same. So we're going to have to find that x-intercept and see what degrees it's at, and then I'll show you why that makes sense. So second trace, you're going to go to number 2, 0. I want you guys to find the x-intercept. So go to the left bound, right bound of your graph, and you should see that at 30 degrees, there is an x-intercept. So if you take 90 and divide it by 3, that's why it gives you your new x-intercept at 30 degrees. So that's my new value that you want to draw it through. And then at 180, if you divide that by 3, you should see that that is where -1 actually occurs, at 60 degrees. And then if you press 90 and trace, you can find that that's your new x-intercept. So it really does change the image, or it squishes it down if you really look at it. And then you want to do each of those values at trace 180. You should find that it's at -1 again. And then if you go trace, I'm actually going to do trace 120. And that gives you at 120 degrees, guys, it should give you 1. and then trace 150. So I'm just going up by 30 degrees just to see where it is. So every 30 degrees, something will happen. So 150 is my next value, and that's where you have an x-intercept. And then at 180, it's actually going to be an invariant point. It's going to be the same on the original, and the y equals 3x, cos 3x. And then if I add 30 degrees to 180, that takes me to 210. So trace 210, that gives me my next x-intercept. And I'm just continuing the shape. And then trace 240. So again, I'm adding 30 degrees to it. That gives you a positive 1. So this is how I'm graphing it. And then my x-intercept occurs at 270. So that's another invariant point. And then if I add, so that's going to be trace 300 now, -1. Trace 330, 0 degrees. And at 360, it should go back to your maximum value. So make sure you always round the maximum and minimum values. And they want you to state the period of the function and compare it to y equals cos of x. Okay, so for our first one, the period is going to be, the period is normally 2 pi, or in this case, because we're in degree mode, we have to continue in degree mode, so we're going to say 360 degrees. And now all you have to do to find your period for the other one is take 360 degrees divided by your b value, which is 3. Okay, so that's going to be 120 degrees. So to get this value, I did 360 degrees divided by the absolute of b. And b is the value in front of x, which was 3. So that is your new period. And another thing we can do to compare is, we know that the amplitude, so this was the period, the amplitude will be 1 in each case. So that's why the heights didn't change. They were at the same maximum and minimum value. So those did not change. Now they want us to sketch what cos of 1/3 of x looks like. And we want to use the domain from 0 to 6 pi now instead. So we want to go from 0 to 6 pi. Okay, so for this one, we want to take 6 pi and see how many times we should split it up. So 6 pi is equal to 360 times 2, or times 3, 360 times 3. So what I'm doing is I'm dividing it by 12 to see how many grids I have, and I know that I should split it as 90 degrees. So each one of these will be 90 degrees, so this will be pi over 2. And then this one will be 180, which is just pi. And then if you add another 90 degrees, that takes you to 3 pi over 2, and then it's 2 pi. So I'm just figuring out what my kind of intervals are going to look like. And then it continues all the way to 6 pi. Okay, so I'm adding pi over 2 each time. So 2 pi plus pi over 2 will equal, so that will be 4 pi over 2 plus pi over 2, which is 5 pi over 2. And then you keep just continuing on. 5 pi over 2, we add pi over 2, and that gives us 6 pi over 2, which is 3 pi. And then we have 3 pi, which is 6 pi over 2, and we add pi over 2, and it gives us 7 pi over 2. And then 7 pi over 2 plus pi over 2 gives us 8 pi over 2. 8 pi over 2 is 4 pi. And then 8, so that'll be 9 pi over 2. This will be 10 pi over 2, which is 5 pi. And this will be 11 pi over 2. And finally, 12 pi over 2 is 6 pi. So that's how I kind of split up my intervals. I want to make sure that I can see all these different values here. And then we don't have a vertical stretch. There's no value in front of cos, so our window will still be the same. It's still, our y coordinate will still go from -1 to +1. So we're going to go from -1, 4 intervals, 1, 2, 3, 4, up to +1. And then what we can do is put the rest in our calculator. We're going to put y equals cos of 1/3 x, close your bracket. Change your window to go from 0 to 6 pi. Keep your y minimum as -2, your y maximum as 2, and then make sure your mode is in radians mode. Graph it. And then we're going to start by doing trace. So press trace and go trace of 0 equals 1. So that's our first point. And then we can figure out what the next values are. So we can go continuing on, we can go trace. And I do want to change the interval as well. So when I go to my window, my scale can go up by pi over 2. So you can change your scale to be pi divided by 2, and that will give you cleaner kind of intervals, and that will show you where it's going through the x-axis. So I'm looking at my graph, and I know it's going to cross at the third interval, which is if you go trace 3 pi divided by 2, you should see that that is an x-intercept. So I'm going to plot going through those. And then another 3 intervals will be the minimum value. So at 3 pi, if you go trace 3 pi in your calculator, you should see that that is where it's equal to -1. And then every 3 intervals, 1, 2, 3, 9 pi over 2. So trace 9 pi divided by 2. That should be where it's at 0 again. And then at 6 pi, if you put in 6 pi into trace, you should get that that is where it's a maximum. Okay, so that is what my graph looks like here. Now, state the period of the function and compare it, sketch the graph of the function for 0 to 6 pi. That's all they wanted us to do. And then they want us to state the period of the function and compare the graph to cos of y equals cos of x. Okay, so when we're comparing it, we have cos of x here, and we have cos of, in brackets, 1/3 x. So in this one, the period would be actually, since we're in radians, it would be 2 pi. And here, we're actually making sure that we flip that value, so it's going to be multiplied by 2. So it's actually going to be, what you're calculating is 2 pi divided by your b value, which is 1/3. So if you put 2 pi in brackets divided by 1 divided by 3 in brackets, you should get that that is equal to 6 pi. So that's the entire section is equal to 6 pi. So it's pretty much like taking 2 pi and multiplying it by 3. That's your period. And then your amplitude for both of them is going to be 1. Okay, so you don't need to write it. They weren't really asking for that. What we are going to do as well is we're going to compare it to the cos of x graph. So remember, the cos of x starts at 1, and then at pi over 2, that's where it touches the x-axis. And then at pi, it has -1. Then it has the x-axis at 3 pi over 2. And then at 2 pi, it reaches its maximum. And then it would continue that same cycle. So this would be one cycle, and you would have to continue that. So you'll see that there's more revolutions within this, within cos of x. So this is what cos of x would look like within that same domain that they gave us. And for our last question, they just want to know what is the period of the graph of y equals cos of -3x. So for this question, guys, make sure that you're just taking the absolute of that value there. So it's still going to be 120 degrees if you're in degree mode. So it could be 360 degrees divided by 3, absolute of -3, which is 3. 360 divided by 3 is 120 degrees. Or if you're in radian mode, you'd have to go 2 pi divided by the absolute of -3, which is 2 pi over 3. So that would be the period when it comes to either degree or radian mode, depending on how they're asking the question. Okay, so that is example number 2. Example number 3, they want you to graph 3 sine of 4x, showing at least 2 cycles. So what I need to do is I need to find the amplitude, which is your a value, and that's equal to 3. That's your vertical stretch factor. Your period in this case, we are, it's not telling us what mode we're in, so we're going to I'm going to do it in radians mode, just to practice that. So our period would be then 2 pi, so our b value, our period is always equal to 2 pi divided by the absolute of b, which is 2 pi divided by 4. So that would be then pi over 2. And so that would be 90 degrees if you were in degree mode. Okay, so that's going to be important because we need to kind of stretch out pi over 2. And we want 2 cycles of this. So if we want 2 cycles will be then pi over 2 times 2. And that equals pi. So we want to stretch this out so that our cycle goes up to pi. So we can write 2 pi here if we're comparing it to sine of x. And then halfway, we'll write pi. So our graph will only go up to pi if we're doing it along that line. Okay, so another thing is the max and minimum values. Well, it's going to be affected by that vertical stretch. So our graph is actually going to be the max value, usually is at 1, but we're going to multiply it by the stretch value. So our max value is now going to be 3. So it's going to multiply by the amplitude. Our minimum, -1, is going to multiply by the amplitude of 3, and you're going to get -3. The x-intercepts are going to be affected by that 4, which is the factor of 1 over 4. So normally, we would have an x-intercept at pi over 2 and then 3 pi over 2. But in this case, we have to divide that number by 4. Okay, so normally, I'm just going to write it to the side. Normally, we have x-intercepts at 0, pi over 2, and 3 pi over 2. So what we're doing is we're taking those numbers and we're dividing those numbers by 4. Okay, so you can also graph it. So I would ideally graph it and then look at the x-intercepts. Okay, so when I graph it, I'm going to put 3 sine of 4x in brackets when I graph it, and then I'm going to graph it in radian mode. So mode, radian mode, graph it, change your window. So you want to have your window going from 0 to pi, so slightly higher because you don't want to cut it off. So I'm going to go from 0 degrees to actually slightly lower. So I'm going to go from negative pi to 2 pi just to stretch it out and see more of it. But again, when I draw it, I'm only going to draw, it says to draw at least 2 cycles, so you could continue if you really wanted to. My scale here, guys, is going to be, I'm going to divide it by, so pi is being divided by 1, 2, 3, 4, 5, 6 sections. So pi is being divided by 6 sections. So this number is pi over 6. So that's something to keep in mind. That would be for your window, your scale. So put pi divided by 6 for your x scale. Your y minimum, I'm going to go from negative 4 to positive 3 for your y minimum and y max, because actually, sorry, negative 4 to positive 4, because you want to make sure you go slightly higher than your min and max values. And then we can graph it. Okay, so you'll notice that there's an x-intercept at 0, so that's one of the x-intercepts. Another x-intercept occurs at pi over 4. So at pi over 4, so pi over 4 is 45 degrees. So I'm just going to draw the rest of this. So this would be 45 degrees, guys. Here would be pi over 2, and then half of that. So this would be where pi over 4 is. That's where your x-intercept is. So every 45 degrees, guys, if you keep adding 45 degrees, that will take you to your x-intercepts. So trace, if you go pi divided by 2, that would be your next x-intercept. There's an x-intercept right there. Then halfway again, and then pi. These are all x-intercepts. So I'm graphing those first. So I'm going to write down those values. So I have pi over 4. I have the value of pi over 2. And then I have so I just want to rewrite this one. So that would be 3 pi over 4. And then we have pi. Okay, so that would be within one kind of interval. If you want the general form of this, it would look like this. Pi over 4 n. So n is an element of integer. So every pi over 4, if you add that either positively or negatively, that would be an x-intercept. So that would be a way of writing that for the general form. And the y-intercept, guys, is going to be at 0. Y-intercept is at 0 because the coordinates are 0, 0, where it starts and where it ends. And now halfway between your x-intercepts, you should always have your maximum value. So I know that my graph is going up to positive 3, so I'm going to write 3 here and then negative 3 here. So it starts off by going up to the maximum halfway between. And then halfway between those two values here, I have a minimum. So always halfway between your x-intercepts, you should have either a max or minimum, just following kind of the curve of it when I sketch it. Okay, so this is what this would look like, and I'll just put an arrow because I do have at least 2 cycles there. So that's drawing 2 cycles. I have my x, my y-intercepts, my max min. The domain would be, now the domain for all these kind of periodic functions would be xer. It does continue forever to the left and forever to the right, so I'm going to draw arrows to show that. And then your range will be going from y is greater than -3 and equal to that, and less than and equal to 3 yer. Okay, so that would be your domain and range. And our last one here, it says example number 4, it says determine the amplitude and period of the sine wave shown. So this one, in order to find your amplitude, it's always going to be your max height minus your minimum, divide that value by 2. So our max height is equal to, if you look at the values, it's going up by 1 for the scale, so our max is 5. Minus our minimum goes down to -5, and we're going to divide those values by 2. So that's like saying 5 plus 5, which is 10, divided by 2. Our amplitude is 5. Our period, what you want to do is you want to trace out what one cycle looks like. So I'll show you what that looks like. So as you can see, guys, we start at the value of 0 here. So we want to figure out where it goes and touches 0 again, but we need to make sure we have a maximum and minimum between those x-intercepts. So as you can see, it goes down to the minimum, then it comes back up to the maximum, and then where it goes to x-intercept, right here, this is your period distance. So the distance that it starts up all over again would be from 0 to 4 pi over 3. So 4 pi over 3, that's the time it takes for us to go to the minimum and maximum value and return to our starting value of y equals 0. So that is your period. Okay, so that's it for our 5.1 lesson. It's just about figuring out the features, graphing them, being able to change between the modes of degrees and radians, and then just finding those x-intercepts is the one tricky part that you just have to practice. Okay, so I hope you guys understand that.